The question is this. A body vibrates in simple harmonic motion with a frequency of 50 Hertz and an amplitude of 4 meters. Find A, the period, B, the acceleration at the middle and at the end of the path of oscillation, C, the velocities at the middle and at the end of the path of oscillation, and D, the velocity and acceleration at a distance of 2 meters from the center of oscillation. Now, solution to this question. The question here talks about a body that is moving in simple harmonic motion. A body performing simple harmonic motion. A body performing simple harmonic motion. Look at the body, A, B, C. We are given the displacement of the body. Displacement. The displacement of the body, 4 meters. The frequency, we are given as 50 Hertz. 50 Hertz. So a body performing simple harmonic motion. A body performing simple harmonic motion. The displacement, the frequency of the body. Now, from our definition, we said simple harmonic motion is the motion, the periodic motion of a body on a straight path, along a straight path, such that the acceleration is directed towards the center and it is proportional to the displacement. The first part of this question asks us to find the period. What is the period? The period here, T, is 1 over frequency. I told you frequency is the reciprocal of period. Period is the reciprocal of frequency from our definition. So the period is the reciprocal of the frequency. We are given frequency as 50, which implies the period is 1 over 50. And that will give us 0.02 second. 0.02 second. That is the period. The period, we define it as the time to complete one oscillation. Time to complete one oscillation, that is to move from point A through B to C and back to A. So time for one complete oscillation. The next part of the question, the next part of this question asks us to find the acceleration. We are looking for the acceleration at the middle and acceleration at the end of the motion. The acceleration of this body at the middle and at the end. So we can take one of the ends, either point A or point C. Of course, the middle is point B. Look at point B, that is the middle. And we can talk about the displacement here, the maximum displacement. The maximum displacement. Point B is the middle. And from our definition for acceleration, definition for simple harmonic motion, it is the periodic motion of a body along a straight path. The periodic motion of a body along a straight path such that the acceleration is directed towards the center and it is proportional to the displacement. Acceleration proportional to the displacement. At point B, at the middle, if you look at the diagram very well, at the middle, there is no displacement. Point B is the lowest point. There is no displacement, meaning x is 0. At point B, that is at the middle, x equals 0. Therefore, acceleration is minus omega squared multiplied by 0. The acceleration at the middle is 0. There is no acceleration at the middle because there is no displacement. So at the middle, the acceleration is 0. Acceleration is 0. What about at the end? What happens at the end? Now, at the end of the oscillation, at the end, that is at point A or point C. So let's take point A as our guide. At the end of the oscillation, at the end, point A and A, at the end, still A equals minus omega squared x. If you look at the end, that is where we have the maximum displacement. At the end, the maximum displacement. And the maximum displacement is 4 meters. From the question, we are given the maximum displacement as 4, meaning acceleration is minus omega squared multiplied by 4. What is omega? I gave you omega as 2 pi f. Omega is 2 pi f. 2 multiplied by pi by f. Take the square of it, multiply by 4. This will give us 2 multiplied by 22 over 7 by 50 all squared multiplied by 4. And we arrive at the final answer in meters per second square. In meters per second square. Look at my method. Look at my method. This is how to answer numerical questions. First, you list the given quantities. Next, the physics, the correct physics. The correct physics. And the physics here is the formula. Acceleration is minus omega squared x. The next thing is substitution, correct substitution. We substitute minus omega squared multiplied by 4. Omega is 2 pi f, 2 multiplied by 22 by 7 by 50 multiplied by 4. Like I've mentioned earlier, the minus shows the direction. The negative sign there represents the direction, that the body is always coming towards the center. It's always coming back to the center. So that gives the acceleration. And that will be the end of the second solution. The third part of the solution asks us to find the velocities. Velocities at the middle and at the end. You can see for the acceleration at the middle, it is 0, and at the end remains minus omega squared multiplied by 4. Let's go to the next solution. Now, the third part of the question asks us to find the velocity at the middle and the velocity at the end. Velocity. So we are looking for velocity. The velocity is 1 at the middle. At the middle. Let's look at the middle. What happens at the middle? At the middle, we have point B. There is no displacement. Remember, no displacement. There is no displacement. But the body will continue to move. The body will move past B, go to C, and come back to A. So velocity at the middle. What is our formula here? The formula is V equals omega square root of A squared minus X squared. Omega square root of A squared minus mx squared. At the middle, we said A, the displacement is 0. That is, x is 0. X equals 0 at that point, leaving V equals omega square root of A squared. Because x is 0, there is no displacement at point B. This will give us V equals omega A. Omega 2 pi f multiplied by 4, because our A is 4. 2 multiplied by 22 over 7 by 50 by 4. 2 pi f multiplied by 4. And that will give us the velocity in meters per second. Let's go over it again. Velocities at the middle and at the end. The formula for velocity, V is omega square root of A squared minus X squared. At the middle, there is no displacement. The displacement is 0. X is 0. Putting X is 0 here, we have V equals omega A squared. Square root of A squared will give us A. So V equals 2 pi F multiplied by 4. And that will give us the velocity in meters per second. Meters per second. Now, the last part of the question asks us to find the velocity and the acceleration. We are looking at the velocity and the acceleration at a distance of 2 meters. 2 meters from the center. We want to look at the velocity. First, the velocity. Velocity at 2 meters from the center. 2 meters from the center. A point 2 meters from the center. That is like somewhere here, 2 meters. Or somewhere in between here, 2 meters. Velocity is omega square root A squared minus X squared. Substituting therefore omega square root 4 squared minus 2 squared, giving us V equals 2 pi f square root 4 squared minus 2 squared. That is 2 by 22 over 7 by 50, then square root of 16 minus 4 of 12. So this will give us the velocity. The velocity at velocity at a point, 2 meters. Velocity at a point, 2 meters from the center. 2 meters from the center. The last part is acceleration. Acceleration, formula for acceleration is minus omega squared x. That will give us 2 pi f squared multiplied by 2. And that is 2 multiplied by 22 over 7 by 50 all squared by 2. So this gives the acceleration. The acceleration at 2 meters from the end. Acceleration is in meter per second squared. Meters per second squared. Students, we have been able to see a complete solution here to this standard question. The standard question asks us to find the period, and the period, the reciprocal of frequency, 1 over f, 1 over f, 1 over 50. We have also been able to see the acceleration at the middle, acceleration at the middle, and acceleration at the end. We discovered that at the middle, the acceleration is 0. Why? Because there is no displacement at the middle. And acceleration is a function of displacement from the definition of simple harmonic motion, that it is the periodic motion of a body along a straight line such that the acceleration is proportional to the displacement and is always directed towards the center. So acceleration is 0 at the middle, and at the end we have the maximum acceleration, minus omega squared multiplied by 4. Then the next part is to find the velocities. Velocities at the middle and at the end. We discovered we can have velocity at the middle, but there is no velocity at the end. The velocity at the end is 0, because at the end we have the same displacement, 4 and 4. And finally, we have been able to discover that velocity at a point, 2 meters. 2 meters from the center, the velocity gives this. And also, the acceleration at a point, 2 meters from the center gives this. So that is how to answer numerical question. First, you list the given quantities and the question. Then the correct physics, that is the formula, very, very important. Then the substitution, correct substitution with the unit converted. Convert the unit to the standard unit. Very, very easy. And lastly, the correct final answer with the unit. Correct final answer with the unit. No unit or wrong unit, you have your mark being deducted there. So you want to score everything. The correct formula, correct substitution, correct final answer, correct unit. Remember, in physics, you think more and talk less. Thank you.